All right, here we go. So, section 4.2 instructional YouTube video for pre-calculus. Angle's a little different because my little thing that I put my phone on broke. So, using some spare parts now. Hopefully it gets everything the way it used to. So today we're talking about all the 6 different trigonometric functions: sine, cosine, tangent, cosecant, secant, cotangent, and we're going to relate these trig functions to the unit circle. So we're going to go ahead and get started with just what these 6 trig functions are. In general, if you have a right triangle, you have an angle theta. From this angle, you have an opposite side, an adjacent side, and the hypotenuse. Remember SOHCAHTOA? This tells us the relationship. This is a mnemonic device. Kind of tell us, like, hey, remember sine of the angle is the opposite side divided by the hypotenuse. The cosine of the angle is the adjacent side over the hypotenuse, and the tangent of the angle is the opposite over the adjacent sides. So these these trigonometric functions, the input is an angle measure, and the output is the ratio of the side lengths. Right? You learned this in geometry, and you did a little bit of it in algebra 2 at the end, but maybe not all of you turned in your homework from it, because I know, it's what some of the algebra 2 teachers said. Not everybody did it. All right, these are 3 main trig functions, but we also have the reciprocal trig functions. So the reciprocal trig functions are, well, the reciprocals. So here, if I have cosecant, we write that as CSC of the angle. This is the hypotenuse over the opposite, and it's 1 over sine. 1 over sine, or the reciprocal, the flip of the sine, is the cosecant. The flip of the cosine, 1 over cosine theta, is secant, which we write as SEC of theta, and that is the hypotenuse over the adjacent. So you just flip the fraction. And 1 over tangent theta is what we call cotangent theta, cotangent. And that's adjacent over opposite. Adjacent over opposite. A couple other things, noteworthy things that I'll take note of, is the tangent of an angle, where tangent of a number is the sine of that number divided by the cosine of that number. So sine over cosine, right? If I did this, if I go opposite over hypotenuse divided by adjacent over hypotenuse, right? Sine divided by cosine, this would be opposite over hypotenuse times, flip and multiply, hypotenuse over adjacent, right? Opposite over adjacent, right? Tangent is sine divided by cosine. Just something to look at. All right, so we need to know all that stuff for pre-calculus and for your future math classes. You need to know those. Now, how does this relate to what we're talking about with radians and the unit circle from the last video? Well, every point on the unit circle, remember, if we take the unit circle, every point on this circle corresponds to an angle measure. And remember, the angle measure is equal to the distance around the circumference that we've got. So, for example, if I take pi over 4 radians, so this angle right here is pi over 4. On the unit circle, this value right here, which the book likes to call t, is pi over 4, as long as this is the unit circle, right, where the radius is 1. This is unit circle. Remember, the unit circle is x squared plus y squared equals 1. So here, if let's say we take the angle pi over 4, there's a point on the unit circle that it corresponds to, right? And last class we went over that this is root 2 over 2 comma root 2 over 2. Now how does this relate to sine and cosine? Well, we talked about that a little bit already. The sine, if I take sine of pi over 4, if you just plug that in your calculator and you go in radian mode, make sure you're in radians because it's pi over 4 radians. What you're going to get, this is opposite over hypotenuse, right? And you're going to get, well, the opposite here. If I make this a triangle, the opposite is the y value divided by the hypotenuse, which is 1, which is just our y value, and it's going to be root 2 over 2. If you put in sine pi over 4, you're going to get root 2 over 2, or the decimal approximation of it, and that's our y value. Now if I did cosine of pi over 4, right, this is adjacent over hypotenuse, which is adjacent is the x number, so x over 1. X divided by 1 is 1, and this is once again going to be root 2 over 2. Pi over 4 is not the best thing to look at. So let's look at pi over 3. I want you to just plug pi over 3 in your calculator. If you have one, make sure it's in radian mode. If I go sine of pi over 3, I'm going to get y over 1, because it's this triangle that I'm looking at, where pi over 3 is right here. Y is opposite, x is adjacent, hypotenuse is 1. And the y number here on that unit circle, remember, is going to be root 3 over 2. And the cosine of pi over 3 is going to be x over 1, which is going to be 1/2, because the x number is 1/2, the y number is root 3 over 2. All right, and these are things you're going to have to remember and know. Now the tangent, so here, in general, let me write this down. So, on the unit circle, sine of the angle equals the y value of the point, and cosine of the angle is the x value of the point. What about the tangent of the angle? Well, the tangent of the angle, let's say we go tan of pi over 3. Remember, tan is sine divided by cosine. So tangent is sine of theta divided by cosine theta. Well, the sine is the y value. The cosine is the x value. So here we've got the y value divided by the x value. We're starting at 0, 0, so really it's the change in y over the change in x, because it's, well, it goes from this number, from 0 to that number, 0 to that number, right? So it's the slope, the tangent of the angle is the slope of the radius at that angle. So let's say we have the tangent of pi over 3. This is going to be a slope that's positive and bigger than 1, because 1 would be at pi over 4, because x and y are the same. So if I wanted to find a tangent of pi over 3, I'd go y divided by x, so root 3 over 2, divided by 1/2, right? Sine divided by cosine, which is root 3 over 2 times 2 over 1, right? We flip and multiply, which is just square root of 3. So tangent of pi over 3 is square root of 3. All right, so that's just a little intro on finding, or how the unit circle relates to sine, cosine, and tangent. On the unit circle, for a given angle, the y value on the unit circle is your sine of that angle. The x number on the unit circle is, the x number is the cosine of that angle, and then the tangent is the change in y divided by the change in x. All right. 1 second here. Just a moment. Okay. Whew. All right, so let's look at an example problem. This is a little bit different example, but we're gonna need maybe not the best order for this video. I apologize if it doesn't kind of flow that nicely. Sorry. I think it'll be all right. We're getting all the learning targets in here. That's what's important. Let's say we have a unit circle. No, this works fine. Unit circle right there. We've got this point on the unit circle, which is 12 over 13, comma negative 5 over 13. Right there. We've got this angle, theta, and there's a corresponding, there's the angle, and then there's a corresponding arc, which the book likes to call t. Now remember, if it's on the unit circle, theta in radians is equal to the value of t, right? Because it's on the unit circle. So if I want to find the sine of t, the sine of this, it's the same as finding sine of theta, and it's just going to be the y value on the unit circle. So it's negative 5 over 13. If I want to find the cosine of this angle, or t, it's going to be the x value. So it's 12 over 13. If I want to find the tangent of t, it's going to be the slope of this line, or it's going to be the y value divided by the x value, because we start at 0, 0, right? It's changing y, we're changing x for slope, but because we start at 0, 0, it's just the y divided by the x. So I'm going to go negative 5 over 12, that's my y value, divided by 12 over 13. So it's negative 5 over 12 times, oh my goodness, negative 5 over 13. Sorry, this is a 13, that's a 13, that's a 13, that's a 13. Sorry, and then 12, oh my goodness. All mixed up, sorry. This divided by this, wrote that here, and then I'm going to flip and multiply, so I get 13 over 12, and that gives me negative 5 over 12 for my tangent. Now let's say I wanted to find all 6 trigonometric functions evaluated here. Well, if I want the cosecant of t, remember the cosecant is the flip of the sine, right? It's the inverse, or not the inverse, sorry, it's the reciprocal function. So here, it's going to be still negative, but it's going to be 13 over 5. If I want the secant of t, that's the reciprocal function of the cosine. So it's going to be, instead of hypotenuse over adjacent, instead of adjacent over hypotenuse over adjacent, or just the flip of the cosine. So it's 13 over 12. And then if I want the cotangent of t, it's just the reciprocal, the flip of the tangent. So it's going to be still negative, but 12 over 5. So that's how you find all 6 trig functions, right? X number's cosine, y number's sine, tangent is the y divided by the x, the sine divided by the cosine. And then for these functions, right, this is the flip, the reciprocal of the sine. This is the reciprocal or the flip of the cosine. And cotangent is the reciprocal or the flip of the tangent. All right. Cool. Let's talk about evaluating some functions given an angle. So this is fun. Let's say we have, and we're going to do all 6 trigonometric functions. So we're going to evaluate all 6 trig functions for a given angle. And that angle is on the unit circle. So I'm going to erase this and we'll go over. Alright, you got to draw a new unit circle. Alright. Wow, this pen is about donezo. Woo. That's much better. Alright, we got our unit circle here, right? Let's say I want to find, right, we want sine, cosine, tangent, cosecant, secant, cotangent for the angle or the arc length, right, because it's unit circle, angle and radians and arc length are the same. Let's say t equals negative pi over 6. Let's say t equals 2 pi over 3. let's say t equals 5 pi over 4, t equals pi over 2, and let's say t equals 2 pi. We're going to get all 6 functions, sine, cosine, tangent, cosecant, secant, cotangent, for all 5 of these problems. Ready? Here we go. Starting with negative pi over 6. Remember, a positive angle goes this way, negative angle goes that way. So I'm going to go pi over 6 this way, so negative pi over 6. And that gives me the reflection of where pi over 6 is. So I'm going to have a positive x number and a negative y number. Right? If we remember what our unit circle looks like, at pi over 6, we have root 3 over 2, and then 1/2 for a y value. So now it's going to be negative 1/2 there. Right? If you just go cosine of negative pi over 6, it's going to be root 3 over 2. So let's just do this. Sine. And the way I did this is I remembered my unit circle from last time. Right? And I said, normally, at pi over 6, we're at root 3 over 2 comma 1/2, and I reflected it. So now the y value is negative. So sine of negative pi over 6 is negative 1/2. Cosine of t, I'm just going to go t because t is negative pi over 6, is root 3 over 2. Tangent of t is going to be sine divided by cosine. So I'm going to go negative 1/2. And if I'm dividing, I'm multiplying by the reciprocal. So it's going to be times 2 over square root of 3. So divide by root 3 over 2 is the same as multiplying by the flip. This gives me negative 1 over root 3. And then I'm going to multiply it by root 3 over root 3 to get negative root 3 over 3. Right? I get square root of 3 on the top. Square root of 3 times square root of 3 is just 3. Alright, now I want to find, and it looks like I didn't give myself enough room, rats. Cosecant, let's still use the green here. Cosecant of t is going to be the flip reciprocal of sine, so it's just negative 2 over 1, or just negative 2. Secant of t is the flip of cosine, so it would be 2 over the square root of 3. I'm going to multiply that by root 3 over square root of 3 to rationalize it, because we don't like square roots in the bottom. And that gives me 2 root 3 over 3. So we get 2 square roots of 3 divided by 3. And then the cotangent of t is the reciprocal of root 3 over 3. So it's 3 divided by square root of 3, multiply it by root 3 over root 3. Once again, we're going to get 3 square root of 3 on top, we get a 3 on the bottom, and it just simplifies to square root of 3. Alright, so that's that one. Unfortunately, it looks like I'm going to have to erase this work so that I can do 2 pi over 3 next. Alright. So for 2 pi over 3, let's do that. Actually, let's jump up here to 5 pi over 4, and then I'll come back and erase this. So 5 pi over 4, I'm going to find that on the unit circle. 5 pi over 4, well, we got to go 4 pi over 4, and then another pi over 4. So this is 5 pi over 4. It's the pi over 4, reflected and reflected. So it's going to have a negative x and a negative y. And remember up here, it's root 2 over 2, comma root 2 over 2. So root 2 over 2, root 2 over 2. But we're in quadrant 3, so they're both negative. So my sine and cosine are both negative here. So sine of t and cosine of t are both negative root 2 over 2. Tangent of t here is going to be our slope, right? It's the y divided by the x. They're the same number, so the tangent's just 1. Now if I want to find my cosecant of t, my secant of t, and my cotangent of t, well, to find my cosecant, I'm going to do 1 divided by sine of t, or the flip, the reciprocal. So 2 over negative root 2. I'm going to multiply that by root 2 over root 2. This gives me 2 square root of 2 negative divided by 2, because root 2 times root 2 is 2. Cancels, and we just get negative square root of 2. Sine and cosine are the same, so cosecant and secant are the same. And then cotangent being 1, or sorry, tangent 1, the flip 1 divided by 1 is just 1. Alright, so that is 5 pi over 4. Let's go over to 2 pi over 3 now. And if you erase this work here, sorry. Remember, it's a video, so you can just rewind if you need it. You need to go back and take notes on that. Just hit that, just drag that cursor over. And get rid of this negative pi over 6 too. Yes, yeah. Alright, 2 pi over 3. Let's find where is 2 pi over 3. Well, 1 pi over 3 is here. Basically, I'm taking this pi. Remember, pi is half of the rotation. And I'm cutting it into thirds. So 2 pi over 3 is this angle, and it corresponds to this arc length on the unit circle. And remember, at pi over 3, the x number is small, the y number is big. So it's, and here, the x number is negative. So I get negative 1/2 square root of 3 over 2. Right? And that's from our unit circle from what was in the last video. Right? It's just this one reflected over. So here, the sine of t is our y number, root 3 over 2. The cosine of t is our x number, negative 1/2. The tangent of t is going to be the sine divided by the cosine. So we're going to get root 3 over 2 divided by negative 1/2, which is root 3 over 2 times negative 2 over 1. The 2's cancel out, and we just get negative square root of 3, which makes sense because it's the slope, it's negative, it's steeper than 1, right? Because 1 would be here at pi, or at 3 pi over 4, right? When the numbers are the same. The y, the change in y is bigger, so it's steep, right? And it's going negative. It's just falling from left to right. So now let's go cosecant of t. Well, that's going to be the reciprocal of root 3 over 2. So 2 over root 3, rationalize it, root 3 over root 3. Right, that gives me 2 root 3 over 3. Alright, did I do that right? My brain's not working. Yes, yeah, that's right. Woo! And now, if I want secant of t, I'm going to flip this, and I'm just going to get negative 2. And then if I want cotangent of t, it would be the reciprocal here, which is negative 1 over root 3. I'm going to multiply that by root 3 over root 3 to rationalize it. And we're going to get negative square root of 3 over 3. All right, so those are the 4 for that. Let's look at, I'm running out of colors here. Let's look at pi over 2. Pi over 2 is halfway to pi. Remember, pi is all the way there, so pi over 2 is halfway, right there. So it's this right angle, right, pi over 2. And it's this point. Remember, it's the unit circle, so the radius is 1. The x number is 0, so 0, 1. So here, the sine of t equals 1, because that's our y value. The cosine of t is 0. The tangent of t would be sine divided by cosine. Uh-oh. 1 divided by 0 is undefined. It's undefined because, remember, it's a slope, and the slope of a vertical line is undefined, right? So we're dividing by 0 here. We can't do that. All right, so now let's say, what's the cosecant of t? Well, it's 1 divided by sine, which is 1. What's the secant of t? It's 1 divided by cosine. What's 1 over 0? It's undefined. What's the, oops, sorry, we already got tangent. the cotangent of t is the reciprocal of the tangent, but remember it's also defined as adjacent over opposite, or x over y, right here. So instead of going undefined again, right, we're going to use the adjacent over opposite idea, or the x over y cosine over sine, and it's going to be 0 over 1. 0 over 1 equals 0, so the cotangent is 0. All right, last one, and that's it for the video. This is it. The last one. What color should I use? Let's use green again. All right, 2 pi, we go all the way to there, and that gives me the point 1 comma 0. The x number is 1, the y number is 0. So the sine of t here is 0. The y value is 0. The cosine of t is 1, because it's just 1. The tangent of t is going to be sine divided by cosine, 0 over 1. That's 0. If I want to find my cosecant of t, I'm going to get 1 divided by sine, right? 1 divided by 0 is undefined. The secant of t is 1 divided by the cosine, 1 divided by 1 is 1, and the cotangent of t is 1 divided by the tangent, which is undefined. Sorry, I got a couple more examples for you. There's one more thing I forgot to talk about. So yeah, that's that. Let's go ahead and do the next examples. That's that. Great. That's how you teach. Just say that's that. Wave your hands and just assume that they get it. Right? That's not how you should teach. Hopefully 5 examples was enough to kind of fill in any blanks though. All right, so if we know sine of t equals 1/3, what's the sine of negative t going to be, and what's the cosecant of negative t going to be? All right, so we're going to look at this. Let's assume, right, well, we know that 1/3 is the y value here, right, and this is t. So sine of t is 1/3. If I have negative t, remember negative t, because it's an angle, right? It's an angle that we're talking about. Positive angles go this way, negative angles go that way. So I'm going to go negative t, and that creates a reflection over the x-axis. So the x number is going to be the same. The y number is now going to be negative. And then if I want the cosecant, right, it's the flip, the reciprocal, so -3 over 1, or just -3. So here we can deduce anytime. There's nothing special about the 1/3 here, right? Any t value, right? If I take any angle and then I take the negative of that angle, it's going to be a reflection over the x-axis, and the y values change, so the sign changes. It changes sign. Well, like S-I-G-N, like positive, negative. So here, sine of t equals the opposite sign, oh my goodness, the opposite positive, negative of sine of negative t. Right, sine of t equals negative sine of negative t. Or you can put the negative over here. Right, if I go negative 1/3, I get 1/3. Let's look at what if we go cosine of t. What if that's equal to, let's say, -3/4? So here we've got unit circle, -3/4 would be like there, 3/4 of the way to -1. So this is the angle t. The angle negative t would be there. So once again, it's a reflection in the x-axis. Now here we have -3/4, comma, whatever the y number is. If I reflect straight across the x-axis, or in the x-axis, I'm going to have the same x number. It's just the y number that changes. So here, if I go cosine of negative t, it's still -3/4. If I want secant of negative t, it's going to be -4/3. Right, just the flip, the reciprocal. So in this case, we can deduce, because there's nothing special about the 3/4, right? We're just looking at t and negative t and that relationship with the reflection, that if I have cosine of t, it's going to give me the same answer as cosine of negative t. So now, think about, if you have tangent of an angle, how does that relate to tangent of the negative of the angle? I'm going to leave that as kind of like the cliffhanger at the end of the video. Hopefully this video was helpful, and good luck on the homework. Thanks for watching.